The robots are coming, however you feel about it. We're seeing them more and more in our lives, creeping, crawling, or even flying into our daily lives. So sometimes it's coming quite rapidly, and it's not often just one cute little thing. Often it's swarms of the things coming at us. So how do we feel about it? In this first episode of our new podcast, we're going to be getting right into the sharp end, getting away from the media hype and actually asking, what do robot swarms mean for us? How they're going to impact us? Can we really trust them? So that's enough of that. I just want to introduce our guest. So Dr. Razanne Abu-Aisheh, is that right?
That's right.
And tell me about where you're from.
So I'm Palestinian. I studied here in the UK, did my PhD in France, and now I'm here back in the UK. So I'm from many places.
And now you're a research associate at the Bristol Robotics Lab.
Yes, the University of Bristol.
Okay, and then but collaboration based with UE as well, University of West of England.
Yes.
Fantastic. Okay, so really I want to get into you. So how long have you been at Bristol? Have you always been into robotics? How did you end up where you are?
Well, it wasn't quite planned. So I've always wanted to be an electronic engineer. So that I knew from when I was very young. My dad's an electronic engineer. I always wanted to do that. So I did my bachelor's in electronic engineering, and then I stayed and did my master's in embedded systems. And then after that, I was like, okay, I'm going to go to industry, going to work there. Did 2 years on like cloud, which is actually software engineering. So like decentralized systems and stuff like that. And then towards the end of my 2-year contract, someone told me about a PhD opportunity in France, which was like this cool mixture between academia and industry. So it was like kind of like collaboration. It's like, I guess I'm moving to France. And that was more on the kind of like somewhere between kind of like electronics and communications and robotics. So it's kind of like this kind of like transition. And I did that on multi-robot systems. And that's where I started to actually learn more about swarm robotics, multi-robot systems, kind of like, and I got into that whole how things are connected, robots working together as a team. And that was 3 years. And then I finished that. And I've actually been here we're not in Bristol right now, but I've actually been at the University of Bristol since April, so not that long. Okay. It's a new thing. And now I'm fully working on swarm robotics.
So your French is pretty good as well then, presumably?
It's okay. It's survival level French. Like I won't, if I'm thrown into France, I won't die from hunger or something.
Yeah, I did a year of my degree in France. And
okay.
I think by the end, I managed to have an argument at the Parisian.
That's better than I can do. I can order coffee and like a croissant in the morning and like,
Yeah. But no, so, France wasn't good enough for you. You thought you'd come to Bristol because it's kind of where it's at, really. You're nearly at Swindon, which I guess is what you're aiming for eventually.
That's exactly what I had in mind. I was like, I have to
get as close to Swindon
move back to the UK to get close to Swindon.
Yeah. So you've done all of this. It sounds like you kind of got really pretty techie, actually. I mean, was that from as a kid? Were you always into this stuff? Or you just been taking stuff apart? Or what?
So it's interesting. Like as a kid, I always wanted to do everything. I was like, every 5 minutes, I was like, when I grow up, I'm going to be like an artist. When I grow up, I'm going to be a lawyer. I just wanted to do everything. And everyone around me was into engineering and they did engineering. And I was like, okay, I guess like you can solve a lot of problems and you can it's very multidisciplinary. So I always even when I was a kid, I understood like, okay, with engineering, you can help people, you can build this really cool kind of like objects. And there was this show that I used to watch, I don't even know, it's called like Totally Spies or something like that. And they had this like gadget, which is a makeup mirror. And then you open it and then it's like this kind of like device and you can communicate. It was this really, I don't even know how they came up with that. And then once I just asked my dad, I was like, if I become an engineer, can I build that? It's like, yeah. It's like, cool, I'm just going to become an engineer. So I don't build those stuff now, but that was my motivation back then.
I think you probably build cooler stuff.
That's true. That's true. Yeah.
But yeah, so it's kind of the creativity side. You want to be able to do stuff. So it wasn't, I'm really good at maths or I'm really good at this. It's kind of, I want to build the cool tech stuff. I want to kind of make things and so it's creativity really, isn't it?
Yeah, it's always like applications for me. Like for me, what motivates me is impact. So it's like, can this help people? I know it's cringy, but like, can it make society better? Can it make the world slightly better? Like things like that. So I always look at it from like what will the impact of this be? in the real world, and then I kind of like work backwards. So it's never been like, oh, start from maths and then how can I use maths, or start from physics. It's always been the other way around for me.
Yeah, okay. I think the when you kind of go from that whole, I think you need that kind of passion, because I think when you go through school, and even if you go to university and get a degree, I compare it to like we were talking about ice hockey earlier, but football or anything, a sport. It's as if, so going to school and going to university is a bit like being in a football team, but you never get to play a game. You're only in training.
Yeah.
It's basically training
Yes.
sessions for years and years and years and years, and never actually playing a game, because you're just learning the tools.
Yeah.
And you don't actually do the science and engineering and actually have the fun stuff till you finish university and actually get your hands dirty and do stuff. Till then, you're just kind of learning what other people have done.
Yeah.
It's kind of like dribbling between cones for a decade
Even
before you
worse
get to play.
sometimes, because like when you're training for like if you're training for sports, at least you know what the outcome will be. Like, okay, eventually this is going to be used in like sports. But like sometimes in school, like we learn like maths, physics, things like that, and we have no clue how we're going to use it in the real world. So it doesn't feel important. It feels irrelevant, and we just see it as this thing that, oh, we have to study to get the mark. Instead of like looking at it from an application side, looking at even like maths. If you think about like, oh, I need to do like my taxes and my bills and calculate discounts at shops and stuff like that, then suddenly it becomes something that's less alien and it makes more sense to us. But it's just connecting the things we learn to the actual way we use them in the world.
Yeah. So it's not like I want to do science, I want to do maths. It's like I want to do cool stuff.
Exactly. I want to be cool.
I want to be cool. I'm struggling, so I'm gonna go the long way around. Yeah, okay, fair enough. And so I think before we get into kind of exactly what you do then, because you do something kind of slightly out there, it feels like, in terms of robotics. But what is a robot? Is there a definition of robot? I've heard definitions. Just to give us context, really.
Yeah. So to make it like as simple as possible, a robot is basically a machine that can fulfill a task in a basically autonomous way or a semi-autonomous way. So for like this machine to be able to fulfill its task, it has to have some ability to move, or some sort of movement involved, and also some sort of processing or computing, so it can make those decisions and fulfill that task.
Okay. So it's taking sensors from the outside world, thinking about it and doing something.
Yes.
And for you, it's important to move. So it's kind of so like your Alexa or something that hears and then actuates a speaker. That doesn't count. That's not a robot to you.
Yeah. So if you look at the actual hardware, so if you think as like a robot as like a body that maybe could embody something else, but if you think of the robot as the actual body, and then as the software is the brain that moves it, then if you think about like, well, you have Alexa, but you can have Alexa on multiple different devices, for example. So it's Alexa is more about the software,
right.
Or the brain part of it. But like if you look at the actual, if you put Alexa on a speaker, then that speaker is not a robot, because it's just it doesn't have any particular function that is fulfilling itself. Whereas a robot can have a brain like Alexa. It can have like something like AI now. That's a big buzzword. That can kind of like help it make decisions. But that's where the autonomous or semi-autonomy comes into a kind of like consideration, because then it has to take input, think, okay, what am I going to do with this input? In a way that will help me fulfill the task I'm supposed to fulfill.
And autonomy just meaning it makes decisions for itself.
Yes.
So when you get a toy,
or it fulfills a task.
You get a toy robot from a shop, and it's remote controlled. It's not a robot because you're controlling it. It's not thinking for itself.
Well, it depends, because because there's two ways. So the thinking part, so let's call it the brain of the robot, can either be on the robot itself, or it can get instructions from somewhere else. So, for example, if you have a toy robot and you're using the remote control, you could be the brain of the robot.
Okay.
Because you're telling it what to do, but then it is moving and fulfilling those instructions, right?
So this is now cyborg territory. This is a human-robot kind of synergy. Okay, fair enough. Slightly getting.
But then that's where the collaboration comes in, right? Because then you can use the robot to fulfill tasks for you, for example.
Yeah. Okay.
So
Okay, and so, but you a particular kind of robotics, because you do swarm robotics.
Yeah.
And I think my first experience or awareness of swarm robotics probably was back when a couple of decades ago, my age, when nanotechnology was the buzzword. Everything was nanotechnology. Every scientist going for grants called their work nanotechnology, didn't they? And Michael Crichton wrote the book Prey. And I don't know if you've read it now, because I mentioned it to you.
I googled it.
Did you have a look? And obviously, Michael Crichton books, they take a tiny bit of something real and then
Yeah.
imagine
Yeah.
a whole lot of stuff outside, and generally it's pretty scary. And in that, they're kind of tiny nanobots that swarm around. I think in that one, you ingested them. They replace bits of your body. You become part human, part swarm robot thing, and obviously it all goes horribly wrong. So that's probably not what you're working on, I guess. But what is swarm robotics? What is a swarm?
So swarm, if you think about it from the word swarm, swarms are a group of robots that work together in a particular way that is inspired by nature. So if you look at a swarm of like bees, a flock of birds, ants, the way they collaborate together.
Right. And murmurations they're the murmurations thing. It's kind of that kind of thing.
Exactly.
Okay.
Yeah. So if you look, for example, we take the murmuration of birds, right? You look at them from far away. They almost feel like they're one entity. They look so coordinated. They do these dances together and these movements. And you'd think like, oh, there must be like each one of them knows exactly what to do, almost like they're choreographed. But that's not the case. They just react to the environment around them. And they kind of like coordinate between themselves locally. So there's no kind of like big brain telling them all what to do. They're all like, each bird is just like, okay, there's 3 particular things, so we need to adjust with regards to like the heading of the group, where they're going, things like even the wind, the robot. I was going to say the robots, the birds next to them.
Are birds all robots, really?
Maybe we don't know.
Okay.
We won't talk about that here. But and then if you think about it, then you see, well, they're actually quite adaptable and flexible because they just react. If 1 or 2 birds just decide to leave the group, you'll still have those beautiful dances. It won't really impact them. And if new birds want to come and join the group, they'll easily find their way to how like to adjust and become part of that dance. And then we do the same with robots. So we just take that kind of like way of cooperating and we program robots in that way so that you have a group of robots. These robots have one objective, one task that they want to fulfill, and they just work together. So they react to each other. Each robot, for example, okay, this robot sees another robot. It's like, okay, I need to make sure I don't bump into it. I need to kind of like go a bit further away. And then you have this kind of like emergent, complex behavior.
Okay, but this, I mean, so it sounds beautiful, and clever. But why? So what? I mean, so murmurations, they look really cool. I'm not really sure why they do that, but they do that before they nest, all that stuff. What are the actual real life uses of swarms? I mean, are they used already? Are they a useful thing, or are they just something that the engineers like to play with because they want to copy nature and get papers written?
Well, some people do it that way because that's how you understand things, right? So some people play around with it to understand. That would be more of the swarm intelligence. But with the robots, one of my favorite application for swarm robotics is search and rescue.
Okay.
Because if you look at like, you have some sort of disaster that happened, there's buildings, there's rubbles, and there's just a lot of victims in there. So time is critical. You want to search and find these victims as soon as possible. At the same time, you want to minimize the danger to the actual rescue team because they're humans as well. So imagine if you have the group of robots. Some of them can fly, some of them on the ground, and they can all collaborate together. And then they can go into these areas, build a map of it, and then find victims and report back to the rescuers. So once a victim has been found, then the rescuer could go in and then kind of like help them out of the rubble. So that's, for example, application. Now, is that really how it is in the real world right now? No, but that's the vision for it. So a lot of people are working and researching on how to move this to the real world. But there are some applications which are more advanced and more closer to moving to reality, such as logistics, which is what I work mostly on.
Okay, so that's like warehouses and...
Yes.
Yeah, okay. Robots moving things around.
Yes.
We have heard some kind of scary stuff about robots kind of going slightly wrong in some of these things recently, haven't we? So these are kind of critical issues about how we do these things in the future. So how do they work?
In terms of like, how do we make sure these things
don't happen? We'll get onto safety later. Yeah, how does it work in the swarm?
So with the logistics, for example, because these robots are adaptable to the environment around them, you can have them in smaller shops that they don't require any infrastructure. So small businesses can just use them to like move boxes around, help them sort things out. Maybe they can even take like items to customers, or if you want to like you want to give out, for example, food. Someone has a food delivery, then the robots can go and be like, okay, this from this, the rice from here, put them in the box and then like take them kind of like to the customer. And the thing that makes them, the advantage that they have is that they're flexible and they're adaptable. And the idea is to reduce their cost so that you can have each individual one is cheaper, so you can have multiple robots. As opposed to like if you go to like bigger businesses, like they can invest in their own infrastructure, their own kind of like robots that are designed exactly for their warehouses. But these robots you can put them, the idea is to have them out of the box, you just put them in the room and then they can kind of like handle the kind of like whatever task you give them.
So rather than like in a big organization where they're going to be doing a lot of the same thing over and over again, and it's they can just pay for it all to be designed specially, and all the algorithms designed specially for what they're going to do. Whereas these out of the box ones, it's more like, if you have this sort of business, the swarm basically works it out. They kind of come out, they've got a few kind of rules, and then they work out what needs to be done.
Exactly.
So I guess they might be less efficient or a little bit less quick than the ones that are specifically designed, but they're much more flexible and I guess you say were more affordable.
Yeah, and that also depends as well, because if you have a large number of robots, they can also be quite efficient if you give them the task to. It really depends on like sometimes like is the speed a critical element or not? Because if they can also fulfill the task the way it's supposed to be fulfilled, and that's all you need, then that's fine. So again, when it comes to like these customized systems versus swarms or like centralized versus decentralized systems, it really does depend a lot on the application that you're using it for.
And that's the kind of distinction, is it, that you kind of said centralized versus decentralized? Yes. So what does that mean?
Yes. So that's a big discussion in the swarm community.
Oh, really?
It's like do all swarms
so I want you
have
to
be
say something
fully?
really, really controversial here that'll get all your co-researchers all over the world complaining about.
That's what I'm good at. Like
Yeah,
if that's what you so if you want to talk about what is decentralized versus decentralized, centralized, as in anything, is like when you have like one, let's say one controller,
right,
and that controller sends out the instructions to all the robots. So let's say that controller is the
like
brain,
a manager,
yes,
and
then
staff.
Exactly. And it's like, you do this, you do that, you do this, you do that. And then the robots do their mission. They kind of like report back. And there's this kind of like, so it has its advantages, such as like, okay, it can make the mission faster. It has more, you have this global knowledge. So you can make maybe more kind of like, you can make some sort of better decisions. But then again, you have this, what we call a single point of failure. So if this
like Star Wars, essentially. They always destroy the single point of failure and blow up the Death Star.
There you go. That's why you need swarms. If Star Wars had swarms,
right.
So then if you have, for example, that controller goes down, then that's it. You've lost control of all robots. Also, you can't scale it up as much because there's a limitations, because you have a lot of communications going on. So you have limited range as to how far out the signal can go, how many messages you can send without them interfering, and stuff like that. So pros and cons. With decentralized, if we say fully decentralized, it means each the robots just interact locally. So within whatever like the neighboring robots are, whatever the environment around them is, and there's not really this kind of like global control or global pool of knowledge or something like that.
Okay.
And then there are things that are in between, which we call kind of like some sort of hierarchical control, something where you can maybe have some sort of semi-centralized, semi-decentralized. So maybe you can have like global knowledge. So they can all, for example, communicate with some sort of cloud, but that cloud doesn't control them. They just kind of like ping it like, oh, I just need this information. So they all send that information there.
So it's kind of, they get on with themselves, but occasionally there's someone intervening going, oh, hang on, can you take care of that over there?
Yeah. So it's kind of like a kind of like in between, or where you could have, for example, like a hierarchy. So you can have, for example, let's say like 5 of the robots have like one bigger robot that is dedicated to being there, let's say supervisor, right? And then you have another 5 which have their own supervisor, and then all the supervisors communicate with one more advanced computer or robot that kind of like supervises them. So this is controversial actually in the kind of like the swarm community, because a lot of people, a lot of scientists think that swarms should be fully decentralized, because they should imitate this kind of like emergent behavior that happens in nature. Also, some scientists think or say that for robots to be kind of like swarm robots, they have to be very simple, very minimal, very small. You have to have like thousands of them and things like that. Whereas like there are other like debates which are like, well, does that have to be the case? So now we're at a point where, because we're working on moving swarms to the real world, these questions are quite important, and people are kind of like discussing these aspects of
And
swarm.
it's not just semantics. It's not just people getting het up with the definition of the word swarm. It's kind of there's some real reason for it. I mean, even bees have a queen, don't they? I mean, there's some hierarchy there.
That's true.
So they are all different. Do have different functions. I'd say that's probably a hierarchical swarm, isn't it?
Yeah. And you can have different. So, for example, you can have different types of robots in a swarm. So that means you have different roles.
Right.
So what if like one of those roles is just like one with a bit more authority, or one with, so yeah, it becomes a very interesting.
Or just search
discussion.
and rescue with the ground ones, the flying ones.
Yeah.
Okay. So, but where you work is you don't design the robots. You kind of don't design the swarms. You work in the kind of the bit that's slightly more. It's actually the whole idea is slightly scary, isn't it? I don't know. I find it. I read Michael Crichton's, and I'm terrified for life of swarms.
That's the perfect thing to read before.
Exactly. And we're just surrounded by, aren't we? The kind of in the media, because the media, I mean, the newspapers, bless them. It's only a story if it's scary or will upset someone.
People want to click on it and read
people want to click on it. It makes you angry, you know.
Yeah.
It's not about telling you things. It's about telling you things that make you react. And like, in sci-fi, we've had decades of sci-fi with robots and swarms, and they're generally, something goes wrong, doesn't it? And there's a lot of things with robots. They call it uncanny valley, don't they? Where if a robot becomes a bit too human, it freaks us out. And so how it's going to feel if we have swarms of robots flying or moving or kicking around, it's a little bit unsettling. And that's kind of where you get in. So it's kind of not quite ethics, I guess. It's trust.
It's trust. It's trust, and it's kind of like interaction, human swarm interaction. So it's like if you look at, so let's talk about the trust aspect first, right? A lot of people, because like you mentioned, like a lot of people who are familiar with sci-fi, or they have this kind of like fear of robots in general, like not even just swarm. If you talk to them, and like people have valid points, right? Because like, especially if you don't fully understand the technology, or you just like think about the worst case scenarios, then that makes sense. But so then the idea is like, we want to understand what people are scared of in terms of technology, what actually is dangerous in terms of like these robots, and how can we actually design them from the starting point in a way that is A, safer for people, and B, actually more accepted by people. So that's why people's perception of robots is very important, because we want to involve people in the design.
Okay.
From the very early stages. So instead of having it being like, okay, let's roll out this technology now and like convince people that you have to trust it. That's not how it works, because you can't force people to trust it.
Because people just reject it.
Exactly. So it's from the so you have to design it in a way from the very beginning that is trustworthy, that people would trust. And it's about establishing this relationship between people and robots, and specifically in my case, a swarm. So part of that is, for example, let's say you have a team of a group of you have a swarm basically, and there's a person who wants to supervise the swarm. So it's not fully autonomous. The swarm can do its job, but there's still a human there to make sure that they don't go, they don't do anything wrong, or if one of them needs a battery replaced or something. So there's multiple things they need to understand. Well, first of all, I need to understand what the swarm is doing, right? I have to have this level of, okay, how do I understand that something's going wrong, something's going right? So we need to, what we call, calibrate the level of trust. So we need to make sure that
you're talking about calibrating humans.
Well, I said calibrating trust.
You see people as robots now, is that?
Do I? I mean, maybe I'm starting to see robots as people. That might be what.
We've got one of your robots here from your
swarm. That's true. That's true.
Can we get out and have a look?
Is
that all right?
Yeah.
I had a quick look, but I haven't seen it properly. I'm just going to get it up on here.
Should I move this?
Well, I'll. Am I going to break? Is this expensive?
Please don't break it, regardless of how much it costs.
Okay, it's valuable to you. So I mean, obviously this is going out audio as well. So I've just opened the box. It's like a flight case, and so packed very nicely in kind of
To
polystyrene
keep it safe.
is it's kind of a white circle, like it could be made by Apple. This thing,
It's not.
it's not made by Apple. So I'm gonna lift that out. Hang on, hold that for a second. I'm gonna take the box down.
Yeah.
Out of the way. Yeah, so it's just encased in foam. So okay, so it's kind of this. So it's basically a cylinder, right? So it's circular. It looks like it's about the diameter of a dinner plate, but it's kind of a few inches tall. But it looks like a Roomba, doesn't it? It looks like a little vacuum cleaner, or
does a little
other
bit.
brands. And we probably should mention Dyson for autonomous vacuum cleaners exist as their local involved in the festival. But then, so yeah, essentially it looks like a little bit like that. There's little holes in the side of it, like a little UFO, little windows, and what it looks like a little serving plate on the top, as if we're going to serve sushi.
Yes.
What on earth am I looking at?
It's a good question. It's actually fascinating to see you describe it. It's like a plate, but it's a Roomba, but like it's sushi. So this is a robot developed by our team,
Okay.
the Swarm team at Bristol. We call them the DOTS, so Distributed Object Transport System.
Does everything have to be an acronym in science?
Yes.
Okay, good.
Unless if you like want to have a word that's a sentence.
Nothing
at
gets
the same
funded if
time.
it's not acronym, does it? No. Okay.
And if it's a fun acronym, even better. You get like
Loads of funding. Yeah.
So the name says it. These are designed to transport objects. So this is actually a lifter. So this can go up and down.
Okay.
And then it has sensors on the side to help it kind of like navigate around. So it can do like image processing, and it can kind of like just move around on its own. So it should have wheels on the bottom. You see.
Okay.
There's these little wheels on the bottom.
And a little bit of writing on the bottom. Number 2, no battery, demo, dots, robot.
Yeah, there you go.
Yeah. It's actually
unique, doesn't it? That's how we know Apple didn't make it.
Yeah, because you clearly built it yourself. Well, I mean, that is the thing. It's kind of, yes, it's tech and it's engineering. It's also slightly rough and ready, isn't it? I mean, the holes look like you drilled them. I mean, did you make this in your own lab?
Not me, but the team did make them. Yeah, okay. And we're still making more of them.
Right.
So it's designed by Simon Jones, a member of our team, and we make a lot of them.
Don't tell them I said it looked a bit rough and ready. It's very beautiful.
It's good. It means they're authentic.
They are authentic. Yeah. So there's your non-switch. I won't touch that. So what is going on? It's got the wheels that moves around. This thing lifts up and down. It's got these funny little bubbles, 4 of them, all around the lift.
So these are kind of like optional, can function with and without them. So this, like, if you in our lab, we have this kind of like system on the ceiling, and it can help them kind of like it's an OptiTrack system, so it can track where they're moving,
right,
and it can help them navigate perfectly. That's if we want not perfectly. That's a really bad one, but like really, really well. But then if we don't use that, what they use is the cameras on the side. So we have these tags that look a bit like QR codes. They're called Aruko tags, and you can put them on the wall, and then the robot can kind of like tell where it is kind of with respect to the tag.
Okay. So this is the kind of equivalent of the motion tracking stuff they do for films. Yeah. So where you see Gollum and he's on his suit with the little baubles all over his head.
We have a green screen.
Yeah, so it's kind of the equivalent of that. So that's the kind of, and then the other one is a bit more like when you do Google Street, when you're out and about and you can take a picture and then Google will work out where you are from the picture of the outside world. So this is the cameras. Okay.
Yeah, kind of. But it's not using an exact, like Google has kind of like all the information, so it can locate with regards to that. This is more of just like you put the sticker there and it can kind of like work out, because there's information encoded in that kind of like tag, so it can just figure out the angle with respect to it and how far away you are from it.
Because in this case, you're using it currently still in lab situations.
Yes, but the idea is that you can just print out those tags and then you can put them anywhere. So that's the idea. So we are working on moving these to the real world, and that's where my kind of research comes in.
Okay. So tell me about your use case, because your use case is not search and rescue. It's kind of, in fact, your use case. It's mundane, isn't it? It's like it's using a kind of really day-to-day, real-life kind of situation.
Yes. So so the big picture for these robots is because, like, as you can see, like, it can lift objects and it can move up, so it can detect an object, it can kind of like lift it up. Usually we put carriers on top, so they look like, I don't know how to describe them,
Little
but they're like
boxes, little
a
trays.
box that's open, trays with legs.
Trays with legs.
So it can kind of like, if you put an object on it, the robot can find the carrier or the tray, pick it up, and then take it to a specific location, which can be like a deposit zone. So the idea is that you can use them, the idea is to have them in warehouses or something like that, but we're thinking of like more kind of like different use cases. So one of them is community exchange. So let's say like you have like a small local community, and you just want to exchange objects with a neighbor or something like that. You have something you don't want to use anymore, and you're just like, okay, here you can.
So it's kind of like an extension of Olio, where you kind of put on what excess food you have or excess items. So like Facebook Marketplace, but you kind of automated it because it'll take it around.
Kind of. That's the dream, to have those kind of like just exchanges between kind of like a community, so you don't waste things, so you can kind of like have things. The closer one that I'm working on is a cloakroom, an automated cloakroom.
Okay.
So what if like you show up to a cloakroom, there's no person there, there's just these cute little robots, and they're like, okay, put your coat, put your stuff, and then it goes and deposits them, and then you come back with your app and you're like, I want my jacket back, and it's like, okay, and it goes and they bring them back, and then you have all these, different robots moving around.
And that's case study you use because it's a useful model to try out your theories or what it is you want to test.
Yes.
So what actually are you looking to test? So what you're not testing whether the robots can do the job.
No.
What are you testing?
Whether people will trust the robots.
Okay.
Or not.
Okay. And trust, like you're going to lose my coat, or trust as in it gives me the heebie-jeebies?
So there's multiple levels to it. So it could be like, because there's different ways of measuring trust, right? There's like, it could from the beginning be like, I don't want to give you my coat. I don't trust it. And then it could be like after a while you see it and you're like, okay, now I feel more comfortable with it because it's more familiar, right? There could be different movements. It could be like, okay, now they're moving in a way that's freaking me out. I don't like it. I feel uncomfortable.
If you gave it legs and it moved like a spider.
Yeah, maybe we shouldn't do that.
Yeah, okay.
And then...
we've had some of them at the festival before. People don't like it.
We don't like spiders?
No,
why do they not like spiders?
I know. And we had Boston Dynamics and their kind of robot dog thing. Some people loved it. Some people were freaked out and ran for the hills. And if you ever read, I know that I should stop reading sci-fi. Fahrenheit 451. Have you ever read that book? I mean, they have robot dogs that essentially they chase you down and then kill you with a lethal injection. So that's what it reminded me of. So how just the design, how it looks and how it moves, but you're looking at how it moves specifically.
Well, because they're a group of robots, it's not one robot.
Okay. So like a gang.
So for example, like you said, spiders. Like what if you look at a group of robots moving and you're like, oh, they remind me of like a swarm of bees. I'm scared. Or what if it's like, oh, they're so cute. They look like they're moving like something natural, something more familiar, as opposed to robots that are moving like in such a calculated way. Maybe it's the other way around. Maybe people will prefer something that looks very orderly and very like, oh, maybe it understands what it's doing. It knows what it's doing. So there are interesting studies that have been done in the past as to people's perception of swarm motions, but not their trust. So interesting, like there are some studies where that they had much smaller swarms and they were just tabletop swarms. So they'd like move around. And then when they had more synchronized movements, some people would say, oh, they look like a team. They're cooperating. They're working as a team. Or they'd be like, oh, they look happy. So they just
because they become sociable. They look sociable, don't they, I guess?
Yeah. And because of the synchronization, it seems to be like when they synchronize, people seem to assume that they kind of like working together to reach that level of kind of like synchronization. So it's very interesting how also humans project onto machines, kind of right? Because a lot of our perception of machine is either, as you said, either because of like things that we've like watched on TV, or because they resemble something in nature that we're naturally afraid of, or the other way around. So those are all things that we're looking to explore, because the objective is that we want to design them from the very beginning in a way that is comfortable for people.
Okay.
So whatever, like whichever one we find people to be, for example, if we find that there's this particular motion that people are uncomfortable with, we will avoid designing for that motion. For example, if we find a motion that people are more comfortable with, we will go with that. And then there's a lot of different things as well. So motion is one aspect, which I just focus in general because I'm focusing on human swarm interaction.
Okay.
Right.
Okay.
So for me, I'm thinking about, well, if there's a human in the loop, a human who has to actually check what these robots are doing, monitor them, things like that, then I need to make sure that they don't, for example, get something called cognitive overload, so they don't get exhausted by too many movements, for example.
So the human doesn't get exhausted.
Yeah, because
so they just find it a bit overwhelming.
Maybe,
Okay.
yeah. So that's also that would be like a next step to look into, because it's not just, there's multiple layers of interaction. There's a user who's just, if we say the cloakroom, right, who's just putting their coat and then leaving. So they have to trust it in terms of, I just need to make sure I'll get my coat back, right? But if let's say your job is you're like an operational engineer and you have to make sure that everything's going well with the swarm, then you need to be able to know when something's going wrong, when something's going well. So you know when to intervene and when not to. So all of the kind of when we design swarms, you have to take all of those things into consideration from the very beginning to make it as comfortable for people to work with.
Yeah, okay. So it's not as simple as you put little faces on them and people think, when I refer
even
to
though people
either
like
cute or
faces
scary,
on
people like a
robots.
face, do they? Yes, that's the thing. It's kind of how much you humanize them, or do you go the other way and make them fully, they just do straight lines and they're like robots and they're kind of, which one feels more comfortable is essentially, but the movement of that. So do we like them that go straight lines, 90 degrees, or do we like them that bumble and feel a little bit like little idiots?
There are these studies that show that like when robots make mistakes, people tend to like them more.
Oh, they're like endearing.
Because they're like, oh, this is more relatable. It's not perfect. It makes mistakes like me and stuff like that. So like whenever I ask people, because now we're setting up trials to actually test this out in the real world. But like when I ask people about like both movements, they're like, oh, I think some people are like, no, I like the ordered one. I like things to be ordered, and other people are like, oh no, I think I prefer the natural, the one that looks more natural and looks like it's just working on the go, because it doesn't feel like there's kind of like someone who's telling you what to do.
Too clever and too sinister. Don't want it to be too clever and too sinister.
Yeah, you want to feel like it's a bit.
So it's kind of so again, I'm getting back into sci-fi. Alien movies. They always have a cyborg, don't they? And they're very cold, very calculated, very intelligent, and do everything, and actually no mistakes.
And then that moment they make a mistake, you're like, oh.
The moment they make a mistake usually means in the film they've gone wrong and they're about to murder you.
It's true. That's true.
So that's how the sci-fi goes. But yeah, so you kind of just make them. Does that kind of bimbling movement make them more approachable? Do they have to be straight lines? So what exactly is the trials you're going to be running? As much as you can tell me about them.
Okay, so let's hope.
Are these all commercially sensitive? Are you working with companies or not?
No.
Okay.
So the idea is that because you don't want people who are actually going to be there to actually know what's happening, so that it doesn't. But I highly doubt that it will work that way. So we're going to run trials with different levels of coordination between the robots. So some robots will seem like they're working in a more orderly fashion. Which is maybe more what we're used to with like maybe more centralized systems or things in actual warehouse, what we see, as opposed to robots that look more chaotic or more random, that look more swarmy or even organic in a sense.
Swarmy. New adjective. I like
and
it.
Then the idea is actually to see is people's natural perception. And we obviously in these studies it's important to take into consideration different demographics, different backgrounds. Because one of the things I'm expecting is that people from different backgrounds may have opposite reactions. So I do think that
when you say backgrounds, just mean,
well, it could be a technical background.
Okay.
B, it could be actually where you're from. So it could be maybe even the political system of the country you originally come from, or somewhere you've lived for a long time.
So a more authoritarian system, you might prefer order, or more democratic,
maybe you're more used to
chaos.
everything being so orderly and so perfect, and so everything, maybe you're more used to things being a bit more organic and flexible and things like that.
Yeah. So in Germany,
Obviously,
they might
we'll
expect them to be nice and efficient. Here, we might be completely blown by something being efficient. We're like, this isn't how the world works. Where's the chaos?
It's like when you actually get to the train, it's actually on time.
Yeah.
You're like, what? I was not.
I know, it just freaks us out. I feel uncomfortable.
Yeah.
I'm a Wales rugby supporter, and I get really upset when we're winning because I'm just not comfortable with it.
It's too unfamiliar. We
too
don't
unfamiliar.
like things that are
We
unfamiliar.
like to be underdogs.
Yeah.
So I guess it's kind of cultural background, like you say, political background. I hadn't even considered how that might affect it. I was thinking age and I guess technical. But...
and also age is a thing, but we're not considering participants that are below 18 years old because it's just.
So the areas you're looking at are particularly their technical background or in the groups you're using?
So we would ideally like to have, so it will be an open call for participants. So the idea is that we can have different people, and what we really want to look into is hopefully get people from different, as you said, technical backgrounds, people who, the key in that is like, how familiar are you with robots?
Right.
Because like if we take people from the lab, for example, like I see a gazillion robots every day. For me,
they're pretty comfortable.
Just another robot. You just get used to them. But for someone who doesn't see robots a lot, it will be interesting to see like, okay, they see that. What do they think of just that?
Yeah.
Like you said, it looks like a plate.
Yeah, it's almost like a wedding cake thing. It's kind of
it could be a wedding cake
stand or something.
It could be a fake wedding cake.
Yeah. Okay. So the idea is then to get an idea of, there's not one, we make assumptions about how people react, but actually A, they might react very differently how you expect, and B, they may react depending on the context, their background, all these things. So when you design these for actual real world cases, whether it's search and rescue or anything else, making sure you're not designing something that's just going to freak the population out, because then they intervene more, they kind of stop the robots, they get involved, and that makes it A, not work, and B, potentially dangerous.
And you also don't want to scare people in general. Like you want,
well, it's people to kind of accept them.
And again, as you said, in search and rescue, like that's a very, very specific case where like you need to make sure that the person won't make any sudden movements or anything like that. And then that's why I believe this is important, because like we have to when we design, we have to consider different people in different places. Because if we make these general designs and we think that this is just like one size fits all, the world doesn't work like that. Right. So we have to. That's why, like when we say trustworthy design, it's a whole process of considering different people, different backgrounds, customizing it to kind of like different situations, so that it can be inclusive of different types of people as well from a very early stage of development. So
you're not getting to a kind of, this is how you do it. You're getting to this is how you design them.
Yeah.
So where does the future lie? What's the next thing you'll be looking at, and where do you think the field's going? What are the big questions we're going to have to answer next?
So in swarm robotics now, it's about moving these applications to the real world. So like people have been working on swarms in labs for a very long time now, and now is the stage where we're trying to push these to the real world and move them to the real world. So there are some, for example, some technical challenges, like I mentioned earlier, which is like, okay, so do they all have to be small little robots with thousands of them, or can they be a bit more complex and bigger, like our robots here, for example? So those are more technical discussions. But then the biggest aspect to consider is people. It's people's perception of these systems. Will people accept these systems? Will people know how to interact with these systems in a way where they know, okay, now this robot, something it's doing is wrong. Now it seems to be fine. Like so we can kind of like build relationships with robots the way we would with anything else. And how to make them safe, how to regulate them in terms of ethics, in terms of being able to verify and validate things. So I would say, like right now, it's focusing on like at least for us, we're focusing on swarms for people. So we've done the technology now is quite mature. Now it's more about like, okay, it's the human side of things.
We know we can get the tech to work. We just see if we can get the tech to work with the people. Okay, I mean, the amount I shout at my Alexa when she doesn't understand me, I can totally see if we had these working for us. It's the whole relationship thing.
And even with Alexa, do you say please and thank you? Like sometimes it's stuff like that.
I start with please and thank you.
And then when she doesn't listen for like a bit
then
of time,
the relationship can break down. Yeah.
But like you said, it's a relationship, right? At the beginning, you assume the best of Alexa. If
Yeah.
Alexa doesn't,
Yeah.
you know.
And I think that's the thing. I think it's a kind of research tool, mostly in the lab now, but you're now looking at getting them out into the real world. And robots are arriving. They're kind of there, kind of how I started there. Robots are coming. They're in our warehouses, they're in various places, and they're going to be more and more. And they potentially are force for good. They can do amazing things. But yeah, it's an unnerving thing, but it's something we are going to be doing. So we want to make sure we do it right in the way we want it to be done.
Yeah.
So I think it's fascinating. Your team are coming to the festival, aren't you, this year? And I want to keep an eye on what you're doing. I'm hoping to come see you at the labs at some point. This is fascinating stuff, and it's just going to keep going. The Bristol Robotics Lab is 250 people there, so it's a big
lab.
It's a big area of research that's happening internationally. So I think watch this space, and we'll find out where the future lies for robotics and how our relationship, most importantly, with robotics is going to lie. Thank you very much for coming in. It's been fascinating. Apologies for me bringing in too much sci-fi, but it's been incredible.
Thank you.
Thank you.